Hi dear all, good evening all of you. Welcome you all to brilliant group of institution. Here we are going to discuss the chapter solutions, the NEET 2023 preparation. Today morning we have already finished the discussion about solution chapter. Those students who didn't attend the session, they can also please watch it, and maximum the previous year questions and the type of question we can expect for the 2023 we can discuss here. Dear all, in 2023 NEET examination, even when you consider the 2020, 21, 22, these examination, they are asking solution chapter questions in a simple way. Dear all, solution chapter, if it's a physical chemistry chapter, we can expect around 2 questions, maximum 2 questions we can expect from 8 marks. Careful. So solution chapter, equations wise questions are there, a small theory based questions are there, Van Hoff factor is very important in this chapter, degree of dissociation, degree of association, ideal solution, non-ideal solution, positive deviation, negative deviation, azeotropes, their examples, and colligative property. That is the most expected part from numerical based colligative property. Dear all, colligative property, please focus it. Numerical based questions are most expected one. So dear all, here we have around 32 questions we are going to discuss there, whereas exemplar and that NCERT, fully NCERT based question. NEET examination, they won't ask you a very high complicated level. We can expect a basic level of question. Maybe when you see the question, you may feel that, oh, this only a direct question is there. Yes, such a kind of questions also there in 2020 and 21. So dear all, let us hope is very simple questions and most expected questions we can discuss here from the chapter solution. Remind all of you, maximum we can expect 2 questions from this one, 8 marks. So I think you can able to answer, you can able to give a good answers very fast. So dear all, I'm not expecting a question and answers, like I'm not going to discuss a question and direct answer. First, a few of the questions I will do like that. Maximum I need a support from you, that is like an answers. So maximum try to share the answers, and please try to share this link to all of your friends. Let them useful about these chapters and all. So dear all, I'm going to question number 1. Question number 1, what is a Van Hoff factor? Van Hoff factor I for a dilute aqueous solution of strong electrolyte barium hydroxide. You can able to give a very simple answer and a correct answer. Tell me dear all, what is the answer for this question? What is the answer for this question dear all? What is the Van Hoff factor? What is the Van Hoff factor for barium hydroxide? What is barium hydroxide? BaOH twice, right? Barium hydroxide is BaOH twice. Tell me dear all, barium hydroxide, what is the value? What is the I value? I value is calculated by which equation? I value calculated by, it is the total number of particles. Total number of particles after dissociation or association divided by number of particles before dissociation or association. That's the equation, right? Or we have another equations also, observed colligative property divided by calculated colligative property, etc. So I value normally we are calculating by how many particles we are getting after dissociation or association divided by before dissociation or association. So in this case, barium hydroxide, when it dissociate, we will get Ba2 plus and 2OH minus. So dear all, how many particles you are getting after dissociation? 1 barium, 2 OH. That means 3 ions. So 3 divided by, what is the number of particles before dissociation? That's 1, right? 3 by 1, that's equal to what? 3. So what is the I value of barium hydroxide? That is option 4. Option 4. Yeah, option 4, that means answer is what? 3, right? I value 3. Simple one question, but dear all, Van Hoff factor related, many questions they were asked in the previous years. Careful, let's discuss everything. Which one of the following is incorrect for an ideal solution? Can you give the answer, dear all? Which one of the following is incorrect? And whenever you answering, especially NEET competitive examination, whether they asking correct statement or incorrect statement, true statement or false statement, which all are correct, which all are incorrect, very careful about that. So please underline the term, dear all. Which one of the following incorrect for an ideal solution? What is the answer? Incorrect for an ideal solution. Which one? Yes, Harim, Hiba, Kadi. Which one is incorrect? Which one is incorrect, dear all, for an ideal solution? You know, for an ideal solution, enthalpy of mixing is 0. Internal energy mixing is 0. Change in pressure, that is 0. What is this? Observed pressure divided by calculated pressure by Raoult's law. That is also 0, dear all. Dear all, for an ideal solution, Gibbs energy is not equal to 0. Gibbs energy not equal to 0. It will be a negative value. For an ideal solution, Gibbs energy is not equal to 0. That is a wrong statement. So that means delta G is not equal to 0. That means a wrong statement. Delta G actually not equal to 0 for an ideal solution. So dear all, for option 4 is the incorrect statement for an ideal solution. Remember all of you, enthalpy of mixing, the volume mixing, pressure, that's all are equal to 0 for an ideal solution. But the delta G is not equal to 0 for an ideal solution. Remind all of you. Gibbs energy is not equal to 0. Next, which one of the following electrolyte has the same value of Van Hoff factor compared to or aluminium sulfate? Dear all, aluminium sulfate when split, you will get 2Al3 plus and 3SO4 2 minus. Yes or no? You know, Al2SO4 thrice, aluminium sulfate when split, you will get 2Al3 plus and 3SO4 2 minus. That means, what is the I value, dear all? 5. You are getting 5 ions. So, where or which compound of these following having the I value that's equal to 5? Which one having high value equal to 5, dear all? Tell me, dear all. Which one having I value? Which one having Van Hoff factor I value that's equal to 5? Yes. So K2SO4. Can you tell me, dear all, what is the I value of K2SO4 fast? Just type it fast. Just type it fast. Just a number. What is the K2SO4 potassium sulfate on dissociate? How many ions that we can produce it? How many ions we can produce it? How many ions we can produce it? K2SO4. You know, K2SO4 will give you 2K plus and SO4 2 minus. That means total how many ions? 3 ions are there. Yes, the I value is equal to 3. Dear all, K3FeCN6. Tell me, K3FeCN6, it's a coordination compound. When it's split, how many ions we can produce it? K3FeCN6, when it is dissociate, how many ions we can produce it? Is it 4? Yes, dear all. We will get 3K plus and FeCN6. What is the charge? 3 minus. You will get total 3 potassium and 1 coordination compound. That is around 4 ions we can produce it. AlNO3 thrice. Dear all, it will give you Al3 plus and 3NO3 minus. So how many ions total? It will give you 4 ions. What about K4FeCN6, dear all? That is our answer. K4FeCN6 when split, you will get 4K plus and FeCN6 4 minus. So that means, dear all, it will give you 4 potassium and 1 coordination sphere ion. That's total we have 5 ions are there. So dear all, aluminium sulfate when split, its I value is equal to 5. The same I value we can show only in option 4. So answer is option 4. Yes, most of them all are given the correct answer. So dear all, I value, it's not a simple thing. Concept wise it's easy, but we don't treat it as a, okay, it's a silly thing, question won't come. No, in the previous year question paper, when you observe Van Hoff factor, simple questions are there. Careful. Question number, which of the following 0.1 molar, all are molality same, okay, all cases molality same, 0.1 molar. Which of the following 0.1 molar aqueous solution, which one will exhibit largest freezing point depression? Largest freezing point depression. Which one having larger depression in freezing point? What is the answer, dear all? What is the answer? Which one having largest, highest depression in freezing point? You know, depression in freezing point is delta TF. That's equal to what? I into Kf into molality. You know, dear all, molality is same here because 0.1 molal is fixed for all the solute. And Kf, you know, cryoscopic constant. Kf is cryoscopic constant. That is also constant for this particular solution. And I value is the only one variable. So, delta TF is directly proportional to what? I. That means higher the I value, higher the depression in freezing point. Tell me, dear all, what is the answer? What is the answer for this question? We can able to say most of them are giving option 3. Okay, dear all, you know, KCl will give you K plus and Cl minus where I value is equal to 2 because it's giving you 2 ion. And glucose, you know, glucose C6H12O6, glucose, that is sugar, you know, sugar part, they won't undergo further dissociation. I value is equal to 1. It's a non-electrolyte type. And aluminium sulfate when split, just to be discussed, it will give you 2Al3 plus and 3SO4 2 minus, dear all, total I value is equal to 5. What about K2SO4? It will give you 2K plus and SO4 2 minus, total it's giving you 3 ions. Higher the I value, higher the Van Hoff factor, higher the depression in freezing point or the colligative property. So what is answer, dear all? What is answer? Option 3 can give maximum number of ions or maximum depression in freezing point. So dear all, I value increases mean normally what happen? The colligative property also increases. Careful about that. Next question. Can you read this question and give a correct answer, dear all? PA and PB are the vapor pressure of the pure liquid. Normally we are using P0 A and P0 B for pure components, right? Okay, depends on the question, they change the datas. So PA and PB are the vapor pressure of the pure liquid component A and B respectively for an ideal binary solution. And chi represent the mole fraction of compound A. Okay, and the total pressure of the solution will be, what is the equation we studied for the total pressure calculation by compared to the Raoult's law? If two solutions having pressures, so PA is equal to P0 A into XA, PB equal to P0 B into XB, where P total we will calculate by an equation by clubbing them. What is the equation? Which is the correct explanation or correct expression for the total pressure calculation, dear all? Most of them are going to option 4. Option 4, let me check it, dear all. You know, we have equation for calculation P total is equal to P0 A plus chi B into P0 B minus P0 A. This is one of the equation possible. Otherwise, we can write P total is equal to, instead of P0 A, we can write P0 B. Instead of chi B, we can write chi A. Instead of P0 B, we can write P0 A. Instead of P0 A, we can write P0 B. These are the possible equations to calculate the total pressure of two volatile liquids according to Raoult's law, which is correct among this. Instead of P0 A, they given PA. Instead of P0 B, they given PB. That's only the difference. So what is the answer, dear all? Is it option 4? Is it option 4? Most of them are giving option 4 as a correct answer. Let us check it, dear all. PB plus, I think it's like this, PB plus, yes, chi A into PA minus PB. Yes, option 4 is the correct one. See, dear all, equations. Instead of asking numerical question, they are focusing on, like, they will give you a data and they will ask you which is equation is correct. Just a rearrangement of equations and all. Very simple questions. I will show you one more question related to osmotic pressure the same way. Let us go for the next question, dear all. What is a simple question? A general data, a general theory. Tell me, dear all, Van Hoff factor I, when it undergo dissociation and association respectively, what happened to the value of I value? You know very well, during dissociation and association, what happens to the I value? Come on, all of you. What is the answer? During dissociation and association, careful all of you, which one they are asking first? Dissociation, then association. Careful, okay? Careful. During dissociation, you know, during dissociation, you know very well, I value increases. Because during dissociation, number of particles are increases. So during dissociation, we know I value greater than 1. During association, During association, I value less than 1. And you know, I value is equal to 1 for a particular species. You know, they are non-electrolytes. They won't undergo further dissociation, alright. So I value is equal to 1 for non-electrolyte. During dissociation, I value greater than 1. During association, I value less than 1. So what is the correct answer, dear all? Greater than 1 and less than 1. I think it is option B. There is no doubt. Simple theory basics. NEET exam means, dear all, theory. NEET exam means theory related questions. Okay, means our NCRT is the examination. Okay, next question, dear all. A solution of acetone in ethanol. Repeated question again we are discussing. Even in our board examination we have discussed many kind of example for which one positive deviation and negative deviation, and then even ideal solution also. The examples are very important. Acetone and ethanol. Acetone and ethanol belongs to which species, or there belongs to which deviation? Positive deviation. Okay, let us see, dear all. We have to concern about one data. You may study lot of equations, lot of examples you may study in for an ideal solution, positive and negative deviation. Anyway, dear all, ideal solutions you can able to understand. They have normally almost similar molecular mass, almost similar same type, you know, almost they are similar type. Almost they are similar type, which means, you know, what is the example for a ideal solution? Normal hexane with a normal heptane, benzene with a toluene, normal bromobenzene and chlorobenzene. They have almost similar type, right? What about a positive deviation? They're all positive deviation solutions. When you consider, they mostly contain alcohols. They mostly contain alcohols. Okay, positive deviation mostly contain alcohols. What about negative deviation? They're all negative deviation mostly contain acids. Careful, okay? So ideal solutions masses are almost similar, or the types are almost similar, whereas positive deviation substances or solutions are almost they contain alcohols medium, and negative deviation maximum they contain acids medium, like acid with water, nitric acid with water, hydrochloric acid with water, like that. So here the question, acetone in ethanol. See, they're all ethanol is a alcohol. Alcohol if there, maximum try to prefer which one? Positive deviation. I think the answers are 2. Yes, that's it. So dear all, example for positive deviation and negative deviations are so important. Careful. Next question. The mixture that form maximum boiling azeotrope is. Which one can give maximum boiling azeotrope? Come on. Which one can show maximum boiling azeotrope? You know, azeotropes are 2 types, maximum boiling azeotropes and minimum boiling azeotrope. You know, maximum boiling azeotropes are formed by which deviation, dear all? Negative deviation. And minimum boiling azeotropes are formed by what? Positive deviation. So they are asking you maximum boiling azeotrope means which is an example for negative deviation. Dear all, negative deviation means I already told you they contain maximum acids. So which one? Where is acids present, dear all? Water with nitric acid. So careful all of you. You know, azeotropes are 2 types, maximum boiling and minimum boiling. Maximum boiling azeotropes are, that's one negative deviation, and minimum boiling azeotropes are which one? Positive deviation solutions. Okay, careful about the examples. Next question, dear all, what is the correct statement? Careful, what is the correct statement regarding a solution of A and B exhibiting positive deviation? Tell me, dear all, which is a correct statement for positive deviation? Read all options carefully, give a correct answer. Give a correct answer. Correct statement for a positive deviation. Positive deviation. How many, or which is the correct statement for a positive deviation? What is answers, dear? Hope you read all options. Dear all, it's not our theory MCQ examination. We are writing a very correct. It's a very important examination, you know. So whenever you answering one question, 4 options, you should read very thoroughly, which is the best among that we have to choose. So dear all, positive deviations data you know very well. You know, they won't obey Raoult's law. Therefore, PA is greater than P naught A into chi A. Similarly, PB. Second one, you know, delta H mixing. Delta H mixing is greater than 0. And the third one, you know, delta V mixing is greater than 0. These 3 quantities are greater than 0 for positive deviation. Only 2 things are lesser. Which one? The fourth data, you know, AB interaction is weaker than AA and BB interaction. You know, solvent-solute interaction is weaker than solvent-solvent and solute-solute. What is the last data, dear all? That will form minimum boiling azeotrope. They will form minimum boiling azeotrope, that you know. So, which is the correct statement among this one? You know, 2 is wrong, 3 is wrong, and intermolecular attractive forces between AA, BB are equal to VB, AB. That is only for which one? Ideal solution. This is also wrong. So, what is option A, dear all? Intermolecular attractive forces between AA, BB are stronger. Yes, AA, BB are stronger than AB. Or you can say AB interactions are weaker than AA and BB. Both are same. They will just change the way of giving the options. That's it. So answer is option 1. All are given correct, right? Good. Next question, dear all. Come on, fast. The mixture that shows positive deviation, again positive deviation, which will give a positive deviation. Which one can give a positive deviation, dear all? Positive deviation means mostly they contain alcohol. Positive deviation mean mostly they contain alcohols. Negative deviation mean maximum they contain acids. Careful. Which one having alcohol, dear all? You know, benzene and toluene. Benzene and toluene, that is an example for an ideal solution. You know, acetone and chloroform, chloroethane, and you see chloroethane, bromoethane, same type, right? That is ideal solution. Acetone and ethanol, dear all, acetone and ethanol, that is the one contain alcohol. That shows which one? Positive deviation. Yes, positive deviation mean they contain what? Alcohols. Careful, alcohol. Next question is related to which one? The isotonic solution. What are isotonic solution, dear all? Isotonic solution mean 2 solutions having same osmotic pressure. Same osmotic pressure. They given 1% of weight by weight solution of a compound. It is isotonic with 5% weight by weight of a solution of sucrose. You know, sucrose. What is sucrose, dear all? C12H22O11. C12H22O11. That's a mass of the, that's a formula of which one? Sucrose, you know. What is the molecular weight of the compound will be? Dear all, this type of questions are very simple and easy to score marks, dear all. Dear all, 1% solution of a substance. They don't mention which is the substance. It is isotonic with a 5% sucrose solution. Their osmotic pressures are equal. If their osmotic pressures are equal, dear all, for an isotonic solution, you can equate their number of moles. What is the point? For an isotonic solution, you can equate their number of moles. So let me consider this is the component A, this is the component B. So I can write number of moles of A is equal to number of moles of B. What is number of moles? How to calculate, dear all? Weight of solvent divided by molecular mass. And how to calculate NB? That is WB divided by MB. Substitute all of you. What do you mean by 1%? 1 gram of a substance, right? 1% mean 1 gram of substance. So 1 divided by, that's a weight. What is the molecular mass of that substance that is supposed to calculate? Let us take MA equal to. What is WB? Weight of solute of the second. 5% mean 5 gram. 5 gram. So 5 divided by, what is the molecular mass of sucrose? Tell me, dear all. What is the molecular mass of sucrose? Can you tell me? C12. 12 carbons, right? So 12 into 12 plus 22 hydrogen, so 22 plus 11 into 16. That you studied many times. What is sucrose, glucose, their masses, etc. What is the mass of sucrose? Can you type in the chat box, dear all? What is the molecular mass of sucrose? 3. What is the molecular mass of sucrose? 340, 340, 340, 342, right? 342 is the molecular mass of which one? Sucrose. Yes. So let us substitute 342. So we can calculate Ma. What is the molecular mass of that substance here all? 342 divided by 5. 342 divided by 5 is around 6 something. 6 something. That is correct answer. Which one dear all? Option 2. So remember dear all, isotonic solution. Yeah, isotonic solutions question if they ask. If they are equating to isotonic solution and they are asking you what is the molecular mass, I will show you some more question related to the same. You can equate their number of moles. So number of moles of one component is equal to number of moles of the other. So Wa by Ma and equal to Wb by Mb. You can calculate their molecular mass, etc. So careful all of you. Hope you clear this question. Next question dear all. See, watch it. From the colligative, you can easily answer this question. You may study this question in our NCERT, the board examination. Tell me dear all, what is the answer for this question? Immediately you can able to answer a very good answers and the correct answer. Come on fast. Which is the best method to calculate the molecular mass? You know, by using colligative property or the for colligative property, we can able to calculate the molecular mass of the solute. But which is the best method to calculate the molecular mass of macromolecule, bigger molecule like protein, biomolecule, etc. You know very well, that is what? Osmotic pressure. Osmotic pressure, you know what is the difference? Even room temperature it is possible to calculate, and here we are using molarity instead of molality. So osmotic pressure is the one it is used for best method to calculate the molecular mass of which one? The proteins and biomolecule, generally macromolecules. Okay, next question. A solution contain non-volatile solute of molecular mass M2. Molecular mass is mentioned by dear all M2 instead of what? MB. And molecular mass of solute in terms of osmotic pressure is, see they given M2. What is M2? M2 is the mass of solute. That means WB, our normal term. V is the volume, okay. Pi is the osmotic pressure. This is the thing I told you. They will just ask you to rearrange the equation and which one is correct and all. You know very well. Okay, I think better to wait for 1 minute, right? Can you give a correct answer? Can you give a correct answer dear all? Which is the correct expression for osmotic pressure in this one? Which is the correct expression for osmotic pressure? Which is the correct expression for osmotic pressure? Instead of, normally we are using WB, MB, etc. right? Instead of MB they used M2. Instead of WB they used the M2. That's it. Option 2, that is the suggested answers. Hiba Hafiz. Others, is there any option 2? Okay dear all. What about others? Ebin, Raina, Sania, Hadia, Sriveda, Sarim. Option 3. Okay, I'm getting 2 options now. One is option 2, other one is option 3. Okay, let's try. Dear all, we have an equation. Osmotic pressure pi is equal to I into CRT, where Van Hoff factor not mentioned, so I'm not taking that. So CRT. Or final equation, you know, for osmotic pressure is WB by MB into V into RT. This is the final equation for osmotic pressure. Instead of WB, they given that is M2, small m2. Instead of MB, they given capital M2. So which is the correct statement here all? We need M2, right? M2 means MB. So MB is equal to WB by V into RT by pi. Where is this answer dear all? Where is this answer dear all? Is it option 2? That is option 2, no doubt. Option 2 just a rearrangement all dear all. Option 2 is the correct answer. Next question. Come on fast dear all. Ideal solution indicate, which is a correct statement for an ideal solution. Fast. This type of question we can immediately skip because it's a direct questions. For an ideal solution, which one is correct? Which one is correct for an ideal solution? For an ideal solution, AB attraction is greater than AA and BB. No. AB attraction forces is less than AA and BB. No. Attraction force remain the same in AA and BB. Yes. Let's go with option 3. AA and BB interactions are approximately equal to what? AB interaction. Right. Simple question. Next one. A solution contain 1 mole of alcohol and 4 mole of water. What are the mole fraction of water and alcohol? Normal basic questions. A solution contain 1 mole alcohol. We have 1 mole alcohol and 4 moles of water. 4 moles of water. What are the mole fractions of water and alcohol? What is the mole fraction of water and alcohol? They're all careful. Which one they're asking first? They're asking water first. Water, how to calculate the mole fraction? Number of moles of water, that is 4, by total number of moles, that is 1 plus 4, 5. Similarly, alcohol mole fraction is number of moles is 1, total mole fraction is, so total number of moles is 5. So 4 by 5 and 1 by 5, right? 4 by 5 and 1 by 5, that is option C. Careful dear all in this question. See, concept wise it's a so easy question. You know, mole fraction means number of moles of that component divided by total number of moles. But what is the difference here? Or what is the difficulty here? Not a difficulty. See, don't be panic when you answering one question. Be confident on the question. They given you alcohol first and they given which one? Aqueous second. But they asking you aqueous first then alcohol respectively. So which one is with respect to? That is very careful. So next question. A solution of glucose is isotonic with the same question type of question we discussed just before. A solution of glucose, okay, you know, glucose is given its formula, you know, C6H12O6, okay, is isotonic with 4 gram urea. What is urea? NH2CONH2 per liter of solution. What is the concentration of glucose? What is the concentration of glucose? As I told you dear all, means their weight they are asking. I told you dear all, if they are asking you the isotonic solution question, we can equate their number of moles. So number of moles of glucose, let me take it A, and number of moles of urea, let me take it B. So WB by MB equal to WA by MA is equal to WB by MB. So how can we substitute dear all? We can substitute it as, what is the weight of glucose given? That is supposed to calculate, right? Weight of glucose supposed to calculate. What is the molecular mass of glucose? You know, that is around 180 equal to, what is the weight of urea given? 4. And what is the molecular mass of urea? What is the molecular mass of urea dear all? What is the molecular mass of urea? NH2CONH2. That is around 6 then. What is the molecular mass of urea? What is the molecular mass of urea? That is 6. What's the next digit? There are 2 nitrogens are there. Nitrogen 14 into 2. 1 carbon, that is 12. 1 oxygen 16. And total 4 hydrogen 4. That's around 6 is the first digit. Second, what is the molecular mass of urea? What is the molecular mass of urea? 60, right? So that's equal to what? 60. So we can cut it dear all. So WA is equal to 4 into 18. What is the answer dear all? Is it there? The correct answer is not mentioned, right? The concentration of glucose is weight of solvent supposed to calculate. So no, weight of solvent is supposed to give. So what is the correct answer actually? What is the correct answer should be? They're asking the weight, right? So 4 into 18. What is the correct answer? The correct is not mentioned here. Which one? Option? What is the correct answer we are expecting as the direct answer? Weight of glucose divided by molecular mass, all right, yeah, equal to WB divided by MB. WB WB, that is WB, that's given 4 gram, right? Yeah, 4 gram divided by molecular mass, that's around 60. That is actually 4 into, yes, correct one, 4 into 18 divided by 6, that is what? Option C is the correct answer. Which one? C, that is 12 gram per liter. We'll get it. Next one, the ratio of the value of any colligative property for the colligative, the compound is given Fe4 FeCN6 thrice to that of K2HgI4. They're given two complexes here. They're asking you what is the difference, what is the ratio of their colligative property. Means you have to equate there, you have to take the ratio of their I value. What is the I value for this complex? Tell me, dear all. What is the I value for this one? Which one? What is the I value for this one? Yeah, yes, correct. Yes, in the previous case I told no. It's actually not 4 into 16. Yeah, 4 into 16, not actually that one. So it will come like, we can cut it, 3 we can cut it, we'll get a 3 into 4 will get 12. Yes, correct one. Option C is the correct answer. In this question, I value we have to equate. I value we have to equate. What is that? If they're asking to take the ratio of the I values, means taking the ratio of the means the colligative property, we have to take their which one? I value. Take the I value ratio. The I value for this complex, this complex splitted as 4Fe3 plus and FeCN6 3 minus, means total 4 plus 3, it is giving you 7 ions. So 7. What is the I value for this complex? It's splitted as 2K plus and HgI4 2 minus, means total 3 ions. So take the ratio of their I value. So I value is equal to 7 by 3. It's 2 something, right? 2.3 something. Yes, we will get 2.33. That is option D. Option D. Correct, right? Okay, fine. Next question. Vapor pressure of a solvent containing a non-volatile solute is. Vapor pressure of a solvent containing a solute. So solute particle, if it increases, what happened to the vapor pressure? What happened to the vapor pressure? Which one? Which one? Less than the vapor pressure of solvent? Yes, dear all, you may study it as the number of particles. As the number of particle increases, very well, vapor pressure decreases. As the number of solute particle increases in the solution, the vapor pressure what happen? Decreases. Vapor pressure decreases. So when there is already solvent, if you add a non-volatile solute into that, vapor pressure decreases. So we can say less than the vapor pressure of solvent. So remember, as the number of particle increases, as the number of solute particle increases, their vapor pressure decreases. Next one, elevation in boiling point was, elevation in boiling point is what? Delta TB equal to 0.52 degrees Celsius. When 6 gram compound X, so weight of solute is given 6 gram, was dissolved in 100 gram water. So weight of solvent is what? 100 gram. Molecular weight of X. So what is MB? That is supposed to calculate, where KB is already given 0.52 Kelvin per molar. Dear all, with the equation directly we can use it. Which equation? Delta TB is equal to I into KB into what is molarity? WB by MB into 1000 divided by WA. Let us substitute one by one. Delta TB is already given 0.52. I value, what is the I value? Elevation in boiling point of a, they not mention which is the solute. Such cases I value you can take it as 1. And KB value given 0.52 into WB. Weight of solute is 6 gram. Molecular mass is supposed to calculate, and 1000 divided by what is the weight of solvent here all? Weight of solvent is 100 gram. So what is MB? What is MB? The simple calculation we can do it. Right, 10. Then you can cut it. Yes. 0.52, 0.52. What is the correct answer? I think here 0.52. Yes. MB is equal to what, dear all? That is 6 into 10 remaining, right? 6 into 10, yes, 60. That's answer. So colligative property related numerical is a general one in solution chapter, dear all. Maximum we can expect from the solution chapter. 2 questions, careful. Next one. 3 moles of P and 2 moles of Q are mixed. 3 moles of P and 2 moles of Q are mixed. What will be their total vapor pressure in the solution of their partial vapor pressures are, that means P naught A and P naught B is given, that is around 80 and 60. Dear all, we have an equation for calculating the, when you adding two volatile liquids, right? So when you adding two liquids, according to Raoult's law, we can calculate their total pressure. What is the equation to calculate total pressure? P total is equal to what? PA plus PB. What is PA? P naught A into chi A, P naught B into chi B. Let us substitute directly. What is P naught A? That is 80. So 80 into, how to calculate the mole fraction of A, dear all? Mole fraction is calculated by number of moles of that component divided by total. So 3 divided by 5. So 3 divided by 5 plus, what is the vapor pressure of the second component? 60 into its number of moles, 2 divided by total number of moles, 5. What is the answer, dear all? 240 divided by 5 plus 120 divided by 5. So 240 plus 120 whole divided by 5. What is the correct answer, dear all? What is the correct answer? 240 plus 120 whole divided by 5. That's equal to option C, 72 torr. 72 torr. Okay, so this is related to which one, dear all? Raoult's law, where P total is equal to PA plus PB, that is P naught A into chi A plus P naught B into chi B. Careful. Next one. Match the column 1 with the column 2, mark the appropriate choice. All of you match the following and give a correct answer. Here, actually, you know, maybe from the first option itself, we can able to find the answer. Some of them, they will give very close, only one, they will change it. So careful. What is the correct answer, dear all? What is the correct answer in this question? Option C. Okay, dear all, ethyl alcohol and water. Alcohol and water, we can go to, it's a positive deviation, that means azeotropic mixture. So A is here, fourth one. A fourth, 2 options, not these two. Benzene and toluene, you know, their ideal solution, that is B. And Henry's law, you know, effect of pressure on gas, C. And Raoult's law, P equal to P naught into chi, that is D. So A matching with the 4, B matching with the third one, that is which option? Option C is the correct answer, right? Option C is the correct one. Simple one. Next one. The osmotic pressure of a solution can be increased by. Osmotic pressure of a solution can be increased by. How can you increase the osmotic pressure? There are osmotic pressure is a colligative property, that is I into C into RT. Osmotic pressure is mainly depends on what? Concentration, molarity. So increase the volume? No. Increase the number of solute particle? Yes. As the number of solute particle increases, you know, the osmotic pressure also increases, because pi is directly proportional to what? The concentration. So osmotic pressure of a solution you can increase by the number of moles of solute particle. Careful. And 10%. So this question here, can you able to answer very fast? The isotonic solution question, dear all. 10% solution of urea, that is isotonic with 6% solution of a substance X. If so, what is the molecular mass of X? So dear all, isotonic mean we can equate their number of moles. That means WA by MA is equal to WB by MB WA, what is the weight of solute here? 10 gram. 10 divided by, what is the molecular mass of urea? That is 60, equal to, what is the weight of WB? That is 6%, that means 6 gram. What is the molecular mass? MB supposed to calculate, right? So we can calculate what? MB is equal to 6 into 6, that's equal to what? 36 gram, that is option C. Right? Option C. So this is a third question related to which area, dear all? Third question related to the isotonic solution. Okay, for an isotonic solution. Next one. Which of the following relation is not correctly matched? Tell me. Which of the following relation is not correctly matched? What is the answer? What is the, go to entire options one by one. Which expression is incorrect? Which statement is incorrect? Which one, dear all? Option C. All are giving option C. They are all relative lowering of vapor pressure. What is the equation? P naught A minus PA divided by P naught A is equal to I into mole fraction of B. That's actually the statement. Or you can say P naught A minus PA by P naught A is equal to I into, what is chi B? That means NB divided by NA plus NB. But normally we know for a dilute solution, when you compare Na and Nb, Na is very greater, therefore we are cancelling Nb. But this is correct, dear all. It's chi B, Nb divided by Na plus Nb, that's correct one. Because of a dilute solution, Na is greater, therefore we are neglecting Nb. But don't think it's a wrong one. So that's a correct statement. Which is a wrong statement? You can able to see, dear all, B is a wrong statement, dear all. Degree of dissociation, you know, degree of dissociation alpha is equal to I minus 1 by N minus 1. Careful, see they given N plus 1. That is a wrong statement or the wrong expression. B is the wrong statement, correct answer. Okay. Next one. For which of the following solute the Van Hoff factor not greater than 1? Come on fast. Which of the species their Van Hoff factor not greater than 1? In which case Van Hoff factor not greater than 1? Which case, dear all, you know, NaNO3 split, it will give you Na3 plus and Na plus and NO3 minus. Barium chloride split, it will give you Ba2 plus and 2Cl minus. K4FeCN6 will give you 4K plus and FeCN6 4 minus. But dear all, this is urea. Urea is a non-electrolyte. They won't undergo further splitting in water. Their I value is equal to 1. So answer is which one? Option D. So dear all, ethylene glycol, benzene, sugar, urea, these all are what? Non-electrolyte, sugar and glucose, etc. So non-electrolyte cases, I value is equal to 1. Now, which of the following will have the highest freezing point? Highest freezing point, dear all. Remember all of you, as the number of particles increases, remember boiling point increases, freezing point decreases. As the number of particle increases, boiling point increases, freezing point decreases. So which one having highest freezing point mean the one which give less number of particle. NaCl will give you Na plus and Cl minus, that means 2 ions. You know, sugar won't split, dear all. Barium chloride will give you barium 2 plus and 2 chlorine, that means 3 ions. FeCl3 will give you Fe3 plus and 3Cl minus, total 4 ion. As the value of I increases, dear all, as the value of particles number increases, freezing point decreases. So here the question, which one having highest freezing point? The one which will give lowest number. So what is the answer? Option B is the correct answer. Careful about the data, okay? As the number of particle increases, boiling point increases but freezing point decreases. Now, a plant cell shrink when it is kept in a given as a just to remember or recover the theory, that's all. You know, hypertonic solution and hypotonic solutions are there. You know, hypertonic solution that's having high osmotic pressure where the particle can which one shrink, whereas in the case of hypotonic solution the particle get swell. So dear all, the plant cell shrink or RBC is like that. When they shrink, okay, it will kept in which medium, dear all? So plant cell shrink when it is kept in a hypertonic solution. Option B. Okay, option B. Yes. Next one. The relative lowering in vapor pressure is proportional to the ratio of number of. Careful about this question. I just mentioned a small description regarding this question in the previous question. Relative lowering in vapor pressure is proportional to the ratio of number of. Which one? Careful. Yes. Dear all, relative lowering of vapor pressure is P naught A minus PA by P naught A is equal to I into, what is that? Chi B. That is mole fraction of which one? Solute. Or we can say P naught A minus PA by P naught A is equal to I into, what is Chi B, dear all? That is NB divided by NA plus NB. But normally when during our numerical question and all, we won't use NB in the denominator because we are considering it's a dilute solution where Na is greater, so NB is too smaller, so therefore we are cutting NB from the denominator. So this is actually the one we have for relative lowering of vapor pressure. So relative lowering of vapor pressure is proportional to the ratio of number of solute to the number of the entire solution, number of moles of the solution. So solute molecule to the total number of molecules in solution, that is option C is the correct answer, dear all. Careful all of you. Correct expression is this one, but normally when we doing the numerical, we will cut NB from the denominator because NB is the number of solute. For a dilute solution, Na is greater, so NB is too small, we will cut it only for numerical. So this is the theory. The relative lowering of vapor pressure is equal to the ratio of number of moles of solute to the number of moles of solution. Careful, option C is the correct one. Next one, when a solute is present in trace quantities, the following expression is used. You know very well, if the solute is present in very less quantity, which quantity we are using to express the concentration of the solution, that you also studied in a theory part. If the solute is very less in the compound solution, which concentration expression we are using? Dear all, that is ppm. What is that? Parts per million. Parts per million. Yes, parts per million we are using only when the species are or the solute particles are very less in the solution. Next one, the molarity. Dear all, first part, don't miss it. The molarity, those terms are also important for numerical, okay? Molarity of the solution containing 7.1 gram. So weight of solute is given 7.1 gram. With a solute is given as sodium sulfate, Na2SO4. And its volume is given 100 ml. What is the molarity? Dear all, molarity is equal to WB by MB into 1000 divided by volume of the solution. What is the weight of solute is given? That is 7.1 divided by, what is the molecular mass? What is the molecular mass of sodium sulfate, dear all? You know, what is the mass of 2 sodium? 2 into 23 plus, what is the mass of sulfur? 32 plus oxygen 16 into 4. We all remember sodium mass 23, sulfur mass 32, oxygen mass 16. So overall, what is the value? Substitute here. divided by volume, I think 100. What is the mass of dear all? What is the mass of sodium sulfate? What is the mass of sodium sulfate? What is the mass of sodium sulfate? Na2SO4, 2 sodium, 2 into 23, 46 plus 32 plus 16 into 4, 64. What's the mass total? Alright, 142 C, approximately 7.1, 142 C. We can simply cut it, right? So it becomes 71 divided by 142. 71 divided by 142. What is that, dear all? That is 0.5, right? 0.5 molar. So molarity, dear all, molarity is a easy concept. Density related questions and all. What you practiced in the NCERT, same thing, keep practicing. If the beginning part is also, we can't neglect it. It's also important. Next question, what will be the degree of dissociation of 0.1 molar magnesium nitrate, MgNO3 twice? Solution where Van Hoff factor is given. Van Hoff factor is 2.74. Dear all, you know degree of dissociation is calculated by alpha is equal to I minus 1 by n minus 1. Where what is I value is given 2.74 minus 1 divided by what is the n value of magnesium nitrate? N value is nothing but number of species that's given by the dissociation. MgNO3 when split you will get Mg2 plus and 2NO3 minus total 3 ions. So n value is equal to what? 3. So we can substitute 3 minus 1. That's equal to 1.74 divided by 2. That's nearly. And dear all, don't forget final answer we should multiply by 100 because degree of dissociation is expressed in percentage. What is the correct answer, dear all? What is the correct answer? See, 17 by 2 approximate 8 something. So 8 something. What is that? 87%. That is option B. So dear all, degree of dissociation is calculated by alpha is equal to I minus 1 by n minus 1. Okay? I minus 1 by n minus 1. Now, so I value already given and n value how to calculate? Number of particle dissociated. So that is n value make Mg1, 2 nitrate, total 3. Don't forget to multiply by 100 that you can able to understand by the percentage, you know, degree of dissociation, association expressed in percentage. Dear all, if alpha is the degree of dissociation of sodium sulfate, Na2SO4, the Van Hoff factor I used for calculating the molecular mass is, what is the Van Hoff factor for sodium sulfate? A simple question. Can you give the answer first, dear all? Can you give the answer first? Na2SO4 when split, you know, it will give you 2Na plus and SO4 2 minus. Yes or no? Alpha is the degree of dissociation. What is the expression for alpha? Alpha is equal to I minus 1 by n minus 1. So dear all, alpha is equal to I minus 1 by, what is the n value? N value is the number of species that you are getting after dissociation. There is 2 sodium, 1 sulfate. That is total 3 minus 1. So alpha is equal to I minus 1 by 2. That's equal to what? 2 alpha is equal to I minus 1. What they need actually? They need I. So what is Van Hoff factor I? I is equal to 1 plus 2 alpha. I is equal to what? 1 plus 2 alpha. What is the answer? That is option C. 1 plus 2 alpha. See, here this type of NEET examination, sometime there will be a highly some more steps in the colligative property and all that, but nothing but what we learn in our NCERT, the board syllabus, the same time. But mostly for entrance point of view, they are asking the questions just like their ionic concentration, the rearrangement of equation, some rearrangement in the ions and all. These are the type of question they are focusing on. Which one? The NEET examination point of view. At the moment, very careful by reading the question, and while reading the answers, please concentrate on that particular question. Please don't think like I have to answer many kind of questions and I have to answer some more questions are remaining there, what I want to do with the questions and all. So when you answering one question, please focus on that question. After bubbling the options, you know, there is no other choices. So whenever you answering the bubble or whenever you are going to score 4 marks, Be confident on that particular question. So this is the solution chapter, the basic concepts wise or the basic types of question they are going to ask in this, mostly expecting this 2023 NEET examination. We will again meet with the other chapters. Mostly it will be next to chemistry. We will discuss the chemical bonding, 11th grade chapter, most important, VSCPR theory, molecular orbital theory. Maybe 11th grade topics you may forget lot. Anyway, we can discuss more questions from those chapters from 11th. So thank you all. So I'm winding up the session. We will meet again with some more other chapters, some more important chapters. Remember, around 5% of the overall NEET we can expect around question from solution chapter. Maximum 2 questions we can expect from this one. So keep practicing, all of you. Thank you. Goodbye.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So, young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.